Okay, so everybody's got a piece of graph paper or your prior work. And so today I'm going to give you 3 vector addition problems to do. And I already told you the first one will be the easy one because it'll just be 2 vectors. Second one will have 3, and then the last one will have 5. And we talked about how you carry out graphical addition of vectors yesterday, where we said you draw your first vector, and then on the end of the first vector, you draw your next vector. But the thing that you have to be extremely careful about is that you have to put your protractor on the end of the vector where you're going to draw the next one, exactly the way you would have put it back at your original set of coordinate axes. So if your vectors, first of all, I think you understand, if you don't draw a vector your right length and you're putting a bunch of them together, you're hopeless about getting the right answer, because since one of them is the wrong length, everything else gets thrown off because everything is connected to that one. The same goes for the protractor. You can draw the vector the right length, but if you don't put your protractor just right, it'll point in the wrong direction, so it'll take your vector chain off in the wrong direction, which again means you're hopeless to get the right answer. Just to do a quick sample before I give you the problems and turn you loose on this. Let's see, this one, yeah, so that's, I'm going to give you a, oh yeah, okay. We'll do a, I'll take you through at least what I am going to consider to be the preparatory mental work that you would go through before you actually hit the paper. Because your paper, all 3 of these should be able to fit on this piece of paper, but you're not going to start all of them right in the middle of the paper. And so by taking a look at your master list, you can get an idea about what's the best place to start your problem. Now, this is not the actual problem that you're going to get, but let's say I gave you, what was this other one that we did? A plus H. Now, if you look at your master list and where you drew them all on the coordinate axes, A kind of goes off in that direction, and H kind of goes off in this direction and is not quite as long. So this would be your A, this would be your H. Now, based on what we taught you yesterday, you would never draw both of these like this in the first place. What you would end up doing is drawing A first, and then on the end of A, you would pretend that you have a new set of coordinate axes there. And what that means is, if you put your protractor like this to draw A, you would need to put your protractor on the end of A in exactly the same orientation. Now, depending on what quadrant it points in, you may have it this way, you may have it this way, but you have to have your 0, 180 parallel to all the blue lines. And this is where the graph paper helps you. Because you have a background of horizontal and vertical lines, you guys should be able to orient this protractor anywhere on that graph paper the same way you had it when you were measuring your very first vector. So what you're going to do is you're going to come over and use your protractor here at the end of A, and I'll do this in a different color, to draw H. And at least for this problem, you're now done. You've created your vector chain, but your chain is only 2 vectors long. And once you have completed connecting all of the vectors, you need to create your answer vector, which for those people who were here yesterday, what do we call it?
Resultant.
The resultant. It is always the same letter. And the way that you form it is basically connect the two, and this becomes your R, but you have to point this the right way. And based on what we discussed yesterday, how would you describe to somebody how to figure out which way it points? Okay.
It's like opposite to the flow of everything else.
Okay, that I am going to say in my head, I kind of think of that direction because when you put a bunch of vectors together, it's like following arrows. The resultant is the only one that goes in the opposite direction. Everything kind of keeps leading you along the chain, but the resultant doesn't bring you back to the middle, back to the beginning. It points away. Yeah.
So you had a third after H that like went off to the right.
Yeah.
So the resultant just cut through.
Yes. And I actually have a couple problems here that when you go to create your vector chain, if your chain crosses over itself, no big deal. Because remember, the idea is that if this thing represented, for example, velocities that were overlapping on an object would not go, it would just smoothly go off in one direction because both of these would be acting on the object simultaneously. But this presentation gives it kind of the impression that, oh, you go here, and then you go here, and then you go here, and then you go like over and over and over again, but that's not the way it really works. But you can't address that in this picture. You have to kind of take them one vector at a time. So that means this thing would point here. Now, you have a master list that tells you exactly how long all of the vectors are that you're adding together. Once you create this, you literally have to take your ruler and measure how long this thing is. And that we would just call R without the arrow because that represents the magnitude of your answer. And then to measure the angle of your resultant, you come back to your original set of coordinate axes and you measure around the appropriate number of degrees. Okay? Now, one of the reasons that I make this quick little sketch, and this is kind of a logistics challenge. I'm giving you one piece of paper. I want all of your problems to fit on that one piece of paper. I will tell you in general that if you kind of imagine that your paper is in quarters, each of these problems will fit in one of these quarters. But if I was going to say that I was going to put A through 8, or A plus H here, where would I want to start my original coordinate axes so it fits best into this quarter based on this little thing that I've shown you here? Because when I say, okay, this will fit here, what most people will do is they'll say, oh, well, I'll come to the middle and I'll do this. And I'll say, you're going to waste a crap load of space by doing that. Where should you move this so that you have the most room available for your problem?
The bottom left.
You move it to the bottom left. Because when you look at this picture, your picture is basically, at least here, in the first quadrant. So that means instead of starting your coordinate axes here, you would move it down here so that your problem occupies, you use space available and you don't waste it. So since almost all of you have drawn your master list of vectors, when I put the vector problem up here, or problems that you're supposed to do, you can do a little sketch like this so that you could say, all right, this should fit in this quadrant of the paper, but I'm not going to start necessarily right in the middle. I can shift this to a particular spot so that the problem that I'm going to do, so I don't waste space. Now, if you're, and now there's two things here. This one is very convenient because it fits in the first quadrant. If you're not sure whether it's one quadrant, you could at least get an idea of, is it top half, bottom half, or maybe right half, left half, so that you could shift this thing around to make sure it fits on your paper. Okay. Any questions on this so far? Okay, so the instructions are going to be, I'm going to put 3 problems for you to do here. You are going to do these problems on what I would call the backside of the graph paper for those that were here when they drew all of the vectors. And this is what you need to show me is essentially everything up in this presentation right here. You don't have to tell me exactly what A is, but I want to see A labeled in your picture. And I want to see H labeled. So I want to see the individual vectors labeled with their letters and the arrow. You don't have to put the numbers on there because you have the master list someplace else. I do want to see the R labeled. So that'll be in every one of your pictures, but you don't have to do that little bracket thing. You just need to label R, and I do want you to point where you're measuring this angle from so that I can see that in the picture. And then off on the side, you will have your exact measured values listed for R, with this being the length of it and this being the angle. Now, we are simply using lengths for our vectors. They're not representing velocities or accelerations or forces. And we're measuring them in centimeters, so that this R should have a unit of centimeter on it. So your answer will be a certain number of centimeters at a certain angle. Again, any questions on this? Okay. So I'm going to erase this, and I'm going to put up your 3 problems. Actually, I may, let's see, we got till, I may only put the first one and say, work on this first one today and see how it goes, and then I'll give you the other 2 tomorrow. That'll give me something to record tomorrow. Okay. Problem number 1. Today, okay, so that's the one that I want you to work on. So protractors and rulers are over here, so you guys can take the class period to work on, the rest of the class period to work on this. And if you run into any difficulties, just call me over and we'll take a look.
Where's the list of the